Continuing with the homework on section 2.5, problem 3a says on problem 1a, what is f of x approaching as x approaches negative 1/5? Well, this was the problem on problem 1a, and at negative 1/5, that's where we had a vertical asymptote. So if the graph goes vertical, we are approaching infinity when x approaches negative 1/5. So the best thing to do with these type of problems is find out what's going on at that negative 1/5, and see, the negative 1/5, you get that when you set the denominator equals 0. If you set 5x plus 1 equals 0 and solve it, you get negative 1/5. And where the denominator equals 0 is a vertical asymptote. And a vertical asymptote, the graph goes vertical, meaning that the y values are approaching infinity. 3b says on problem 1b, what is f of x approaching as x approaches infinity? Anytime it says as x approaches infinity, it's a question about the horizontal asymptote. It's asking what goes on in the long run. As x approaches infinity means in the long run. So looking at the horizontal asymptote for this, it's big power, so you need to do this by hand. The power of the top is actually the fourth power, and the power of the bottom, see, because this is second power and this is second power, makes it the fourth power. And the power of the bottom is also fourth power because this is the third power, and over here this is the first power. 3 plus 1 is 4, and 2 plus 2 is 4. Now when the powers are the same, you look at the leading coefficient. Now the leading coefficient on this thing is going to be 2 squared plus 5 squared, which is 100, and the leading coefficient on the bottom is going to be 3 cubed times 7, and 3 cubed times 7 is 189, and 100 over 189 simplifies down to 0.5291. So that would be the location of the horizontal asymptote. On problem 3c, it says on problem 1c, what is f of x approaching as x approaches infinity? So again, it's a question about the horizontal asymptote. So this one, back on problem 1c on a previous video, we simplified this. You had to invert this and factor everything. Different things cancel out, and you're left with this. Now, what is the horizontal asymptote for this? Well, the top is to the first power, the bottom is to the second power when you distribute that 5x through. And when the power of the denominator is bigger than the power of the numerator, then you have a horizontal asymptote at y equals 0. On 3d, it says on problem 2a, what is f of x approaching as x approaches 2/3? Well, this thing's simplified, factored, and something canceled out right there. These two things canceled out. The 3x minus 2 canceled out. And see, at 3x minus 2, that's where there was an undefined point. And so this is saying what is the y part getting close to as x approaches 2/3. So how do we find the y part of the vertex point? The y part of the undefined point. Substitute the x part, the 2/3, and that is the undefined point because you said, you know, where did the 2/3 come from? The 2/3 didn't come from 3x plus 2. The 2/3 came from setting 3x minus 2 equal to 0. If you set 3x minus 2 equal to 0, you get 2/3. So now what is the y part of that? Well, put the 2/3 back in here, not in here, but in here, and simplify it. And I did that right here, and you get negative 0.857. And that would be the answer to that problem. There's actually a hole in the graph, and that's what the graph is getting close to, that height right there of negative 0.857. That's the answer to that problem. On problem 2a, what is f of x approaching as x approaches 3? Well, if you look back at 2a, there's a vertical asymptote at x equals 3, so that means that it's approaching infinity. On problem 2a, what is f of x approaching as x approaches infinity? Well, when x is approaching infinity, it's a question about the horizontal asymptote, and problem 2a had a horizontal asymptote at 3/2. On problem 3g, it says on problem 2a, what is f of x approaching as x approaches negative 2/3? If you look back at that problem, there was an x-intercept at negative 2/3, so therefore it's approaching a height of 0, because an x-intercept is at whatever the x value is, comma, 0. And at negative 2/3, it was an x-intercept, so the y part, what is f of x? That means the y. What is the y approaching? It's approaching the y value right here. Just like earlier on the undefined point, it was the y value that we were looking at. On problem 2b, what is f of x approaching as x approaches infinity? So this is a horizontal asymptote question, and on that problem we had no horizontal asymptote because the power of the numerator was bigger than the power of the denominator. Since there was no horizontal asymptote, it's approaching infinity. It just keeps on going up. It doesn't flatline. So that was 3h. 3i says on problem 2c, what is f of x approaching as x approaches 2/3? Well, here's problem 2c. it factored into this, and a 2/3, look, that's what's going to make this 0. So you would think it's an x-intercept, but it isn't, because that's the same term that that got canceled out. So it's actually an undefined point. But now this is saying what is the y value of that undefined point, and the y value of that undefined point was 0. So if you substitute 2/3 in here, you'll get 3 times 2/3 minus 2, which is 0, over 5 times 2/3 plus 4, which is some number there, 22/3, and 0 divided by 22/3 is 0. So it's approaching 0 is the answer to that problem. On 3J, it says on problem 2D, what is f of x approaching as x approaches 2/3? Okay, 2/3 was came from the 3x minus 2, and look, there's, even on the simplified one, there's a 3x minus 2 left in the bottom, which gave us a vertical asymptote. So since there's a vertical asymptote, it's approaching infinity on this one. On 3K on this one, what is it approaching as x approaches -2/5? The -2/5 came from the bottom, so that's a vertical asymptote, and it's approaching infinity then. So that would be infinity. 3I, on this problem, what is f of x approaching as x approaches infinity? It's a horizontal asymptote question. So there's no horizontal asymptote on this one because the powers, power here is 2, the power in the denominator is 1, so no horizontal asymptote, so it's heading off to infinity. It's heading off to infinity in a straight line. It's an oblique asymptote that's heading up to infinity, but it is approaching infinity. Because there is no horizontal asymptote, it is not leveling off, it just keeps on going up. Okay, and the last problem on this section is a company produced aluminum cans in the shape of a cylinder, has to hold 0.5 liters. Well, first of all, 0.5 liters is the same as 500 milliliters, so we'll have to convert that to 500 milliliters. The top and bottom of the aluminum can costs 0.03 or 0.03 of a penny per square centimeter, and the lateral, the up and down bit, costs 0.02 of a penny per square centimeter. So first of all, we need to get the cost of this can. So let's do this. First of all, we'll need the surface area of the can. Surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. Where did that come from? Well, the area of a circle is pi r squared, and on a can there's 2 circles, the top and the bottom. That's why there's 2 pi r squareds. And then the lateral surface area here, well, that has a certain height and a distance around. The distance around a circle is 2 pi r, and the height is h. So if you take 2 pi r times h, you get the lateral surface, and this is the area of the top and bottom. So you take this and you multiply each part of this by their cost function. So the cost of the circular bit is 0.03. So you take 0.03 times the 2 pi r squared, and the cost of the up and down section, the lateral area, is 0.02. So we take 0.02 times the 2 pi r h. So take the 0.03 times the 2 pi r squared, you get 0.06 pi r squared, and take the 0.02 times 2 pi r h, and you get 0.04 pi r h. Now, hold on to that, and we wanted it to have a volume of 500. The volume of a cylinder is equal to pi r squared h. The pi r squared is the circle bit, and the h is the height. So pi r squared h. So we know pi r squared h, that volume has to be 500. There's too many variables over here. There's r's, cost, c, and there's also an h. We got to knock this down to just 2 variables, and the way to do that is to solve this equation for h and substitute it in over here. So solving this for h, I have to divide both sides by the pi r squared, and I get h equals 500 over pi r squared. Now substitute that 500 over pi r squared in for this h right here, and we'll get this right here. Now, this simplifies a little bit. The pi's cancel out, and this r cancels out with one of these r's, so we're left with this right here. Now we got to get a common denominator, and the common denominator is r. So we have to multiply this by r, top and bottom. That'll give me r cubed over r here, and I already had a 20 over r here, so the common denominator is r. So I can write both of these over one denominator. Now I have that whole thing simplified, and I can use Excel to find out the maximum, or actually the minimum cost is what I'm looking for. So my first coefficient is going to be 0.06 pi. So going to the rational sheet, right here I typed in equals 0.06 times pi, open parentheses, close parentheses, because that's my coefficient for my cubic term. And then I have a 20 for my constant, and on the denominator I just have a 1 right here because I have one r in the bottom. And then all we're looking for is max min type of things. So go down here where we can do search for max mins, click on this, and it says, do you have a restricted domain? Say yes. Now, what's the lowest value that this r could be, a radius? Well, if you have 0 for a radius, you don't have a can. It definitely can't be negative, but it also can't be 0 either. So I just put in a very small number for the radius, like 0.1 or something, where you can make it smaller if you like, but not 0. And then now put in your upper value. Well, how big could your radius be? Well, you can go as high as you want to on this. I mean, if you want to go 100, you want to go 10, whatever you like. I mean, it's how many inches the radius, or how many centimeters wide this radius is going to be of this can. So 100 centimeters is really, really wide for a can, but if you want to do that, you can. And then as soon as you get that in there, it works it out, and it finds that lowest spot right there. And that lowest spot is minimum right here. So the lowest is when this is be the radius. So the radius needs to be 3.758, and the minimum cost would be 7.98 cents, and that would be the minimum. And you can see it here if we look at this graph. Let's go from 0.1 out to maybe 10 or so, and we'll see that it's about 3. That minimum, see, here's the minimum somewhere in here, but it's at about 3 or so high, and so sorry, 3 or so to the right, 3.7 to the right. And how high is it? Well, let's just get a little bit closer to it, and you can see that it's about, between 5 and 10. But here's the exact answer right in here, and that will do it.